Okay, so our last section for this week is part of section 1.3. Okay, we're still going to be solving equations, so same basic goal we've been doing Monday and Tuesday and Wednesday, except now we're going to solve equations where we might have a variable on both sides. Okay, we've never had that before. We've always had all the variables on one side. Okay, so now it might be on two. And that's what I just said. All right, so what's nice is that the steps for solving these kinds of equations are pretty much the same as yesterday. Okay, there's just a small change, kind of a hint we're going to give you when you get to the addition part. All right, so somebody tell me, what does the S stand for? Marissa?
Simplify.
Yep, that's your simplify. Okay, and what's the first thing we always do under simplify? Josh?
Distributive property.
Yep, distributive property, and what else?
Combine like.
And combine like terms. Okay, so what I'm going to do is just switch the order of those two, because you always distribute first. So first thing you do is your distributive property, if you need to. And the second thing you do is combine like terms. Okay, now remember, you guys might not have to do every step in every problem. Okay, but the reason we're showing you all the steps now is so that when we get to a problem that has all the steps in it, you already know all the steps. Okay? I don't think we're going to do a problem that has every single step in it until next week. But you guys will already be ready for it. How about the A? What's that stand for, Emily?
Addition.
Okay, so that's your addition or
Subtraction.
subtraction. Okay, and this is the part where we're going to give you a little hint. Okay, how many people like to deal with negative numbers? How many people rather just keep things positive if you can? All right, so that's the hint we're going to give you here. It's a hint to help try to keep things positive if we can. We can't always, but hopefully we can. Okay, and here's the hint. Yep, so we're going to take the number, okay, that doesn't have a variable, that's smaller, and that's oftentimes the one that we're going to move. And we'll show you an example when we get to that. Okay, so the big idea is we try to move things so that we don't get a negative when we do the calculation. If you do get a negative, that's okay. Sometimes you can't avoid it, but if we can, we will try to. All right, so not only do we have to do addition and subtraction with the numbers, we might also have to move letters from side to side. Okay? This is the part that we've never had before. Okay, so we're going to take the variable that's on the same side of the equal sign with the number, and we're going to move that to the other side. Okay, so what you might have at this step, just to kind of show you, is something like this. Let's say 3x plus 2 equals 5x. So what this step is saying is take the variable, where there's a number and a letter together, that is on the same side of the equal sign as the number, okay, same side as the number, and you're going to move that to the other side. Okay, because the goal when you're solving this is you want to get things with letters on one side, things without letters on the other side. Okay, so we're going to move the number with the variable that's next to the number by itself to the other side of the equation. Okay, if it seems a little tricky, it's actually not that bad once we just do an example. Okay, and then your last step, there's really nothing new with that. That's your multiply or divide step. Okay, and as far as writing down things that are not examples, that's pretty much all we really have to write today for stuff that's not an example. Okay, that's the only notes you need. Okay, now we're just going to look at, I think we'll try 5 different examples. All right, do you guys have the example already written or no? Nope, okay. So that's our first example. All right, so as I start to do this, I'm going to try to follow these steps. Yeah, hey? Yes. All right, first thing, looking at example 1, 7y plus 13 equals 5y minus 3. Can anybody tell me, do I have distributive property? What do you think? About Kyle? No, no distributive property there. If I did have distributive property, what symbols would I see? I would see parentheses. All right. Do I have any like terms on the same side of the equal sign? Okay? Nope. No like terms on the same side of the equal sign. So now I'm going to go to the adding and subtracting. All right. So now this is where I have a choice. Okay? I can either say I'm going to get all the letters on the left, or I can say I'm going to put all the letters on the right. Okay, same thing with the numbers. I can say I'll either move the 13 to the right side, or I'll move the negative 3 to the left. Okay? We've never had this kind of choice before. Let's start with the numbers. Okay, the 13 and the negative 3. What could I do to both sides so that I put all the numbers without letters on the same side, and I don't get a negative? Should I move the 13 to the right? Or should I move the negative 3 to the left? Which way should I do it? Emily?
Move the negative 3 to the left.
Yeah. Can you tell me how I would do that?
You would subtract 3 by 13.
Well, we can't subtract because we already have subtracted 3. So we've got to do something that's the opposite of subtract 3.
Oh, add it.
Yeah, we have to add it. Good. So we have to add 3 and add 3. Okay, Ariel, what happens when I do negative 3 plus 3? Yeah, we get 0. That's gone. How about Marissa? What's on the right-hand side now?
5y.
Yeah, all we have is a 5y. And on the left-hand side, I've got a little work I need to do. I've got 7y, and then I've got 13 plus 3. Shannon? 16. Positive or negative?
Positive.
Positive, good. Okay, what do you notice now about all the numbers? Okay, the things without letters. Where are they in this equation? Where are all the things without letters? On one side. What side are they on? They're all on the left. If you look back up at the top step, where were the things without letters in that step? They were on both sides. Okay, we don't want that. We want them all on one side, and now we have done that. Everything without a letter is on the left. So that means everything with a letter, we're going to put on the right. Now, we avoided a negative at that step. I'm not sure we're going to be able to avoid a negative at this step. Okay, so sometimes you just have to deal with the negative. So my next step, I still have some more adding and subtracting to do. Does anybody see what I could add or subtract to get all my y's on the right side? Yeah, what do you want to subtract? Yep, subtract 7y. And where else do you want to subtract it? From the other side. Okay, so now when we do it, 7y, take away 7y, that's gone. And Liam, what do I have on the left? Yep, just the 16. And how about on the right? That's 5y, take away 7y. Careful, that would be 7 take away 5.
Oh,
This is 5 take away 7.
negative 2?
-2, yep. So we get -2y. And now we're down to the kind of equations we had on Monday and Tuesday. One step. Okay? Is there any more adding and subtracting to do here? No. We finished that step. Sabrina, what would be my last step?
Divide and negative 2.
Yep. And then divide each side by -2. Okay, and how about Brett? What's -2 divided by -2? What happens there? Yep, the numbers and the negatives cancel. And you're left with y on the right. And Emma, what's 16 divided by -2? Careful, I like the number, but what's a positive divided by a negative? Negative, so -8. And that's our answer, -8. Okay, any questions on the steps we did there? Okay, we're gonna try another one of those too. All right, so it was kind of nice we avoided the negative to start with, but we couldn't avoid it for the whole problem. Okay, but you can always try to avoid it when you're starting out. All right, example 2. All right, this one's definitely, I'd say it's one step harder than the last one. But I don't think it's anything you haven't really already done in last night's homework. Kaylee, do you see what I'm going to have to do in this problem that I didn't have to do in the last problem? Yeah, we're going to have to combine like terms right away. We didn't have to do any simplifying in the last one. There were no like terms on the same side. This time there are. Who can tell me on what side do I have some like terms? Liam? Yep, on the left. Can somebody else tell me what the like terms are that I'm going to combine? Shannon?
8h and negative 3h.
Good, I like it. 8h, sign to the left, always goes with it, and negative 3h. And now lastly, can somebody tell me what I get when I combine 8h and negative 3h? Kyle? 5h. Yep. Okay, what do I do with everything else that's in the equation that I didn't circle? Just bring it down. So we have 5h plus 5 equals 8h minus 4. All right, so now we're going to focus on the numbers, okay? Things without letters. You can either move the 5 to the right or move the negative 4 to the left. Which way do you guys want to do it? You can get the correct answer doing it either way. But I think if you pick the right way this time, you won't have any negatives in the whole problem. If you pick the right way to do it. Josh? Yeah, we're going to add 4. I like that idea. If you do it that way, I think you're going to avoid negatives for the whole problem. So we're going to do a plus 4. Where else do you want to do it? Yep, and where do I put it? Under the 5h or under the 5? Under the 5. It's 4. And you're doing good, Josh. So can you tell me what's left here? Okay, I like that. Okay, he added 5 and 4 and got 9. Brought down the 8h. And negative 4 plus 4, that is gone. Okay, so now we had an equation. Originally we had numbers all over the place, on the left and the right. Now we only have things with numbers on the left. So if I've got things with numbers on the left, where are things with letters going to go? On the right. Good. Okay, so if I'm going to move that 5h to the right, am I still doing adding, subtracting, or am I now multiplying and dividing? Oh, Brett? We're still adding and subtracting. Okay, that's the thing. With these kind of problems, there's a little bit more adding and subtracting. Okay, so can you go ahead, Brett, tell me how you're going to move that 5h? Yeah, subtract 5h. Subtract 5h. And can you tell me what I'm left with? 3h. Okay, 3h, where are you going to put that? Left or right? Right. Yep. And what about on the left? 9. Okay, and now again, we're down to our easiest kind of equation. This is one step left. How about Natalie? Are we going to be doing adding and subtracting here now to get h by itself? No. What are we going to do? We're going to do dividing. And what are you going to divide by? Perfect. Divide by 3. Divide by 3. And Sabrina, can you tell me what h comes out to? Yep. H equals 3. Perfect. Okay, you're not wrong if you started out and you said, you know what, I'm not going to put the 4 on the left. I'm going to put the negative 5 on the right. That's fine. The only difference is you're going to have to deal with negatives, but you can still get the same answer. Okay? So now you've got choices on how you want to solve it. But if you can, try to keep the numbers positive. I think positive numbers are easier than negatives. All right, so example 1 and 2. These are the most typical kinds of problems. Okay, when you go and solve them, you always get a single answer, and you're done. Okay, well, there's 2 special kinds of equations that come up. Okay, so this part I just want you to look at. You don't have to write it. It's what we're going to do in example 3 and 4. Okay, how many solutions did I say the last problems had? They each had how many? Josh? 1. Okay, in this problem, the answer was h equals 3. That's a single answer. This was y equals negative 8. That's the only answer. Well, sometimes when we solve some equations, we try to solve it, and we get an equation that's impossible to solve. Okay? We call that a no solution. Okay? Well, sometimes we get an equation that's just the opposite. Any number is a solution. So there are really 2 totally different cases. One type is going to have no solution. The other type is going to have as many solutions as you want. Okay? So when we have no solution, we just call that a problem that's no solution. When we have an equation where any number that you can possibly think of is a solution, that's called an identity. Okay? An identity is an equation that's always true. In fact, you can't find a number that makes it not true. It's always true. Has anybody ever heard of that before? In math, an identity? We'll see one type that's a no solution, so I'll show you what happens then, and then I'll show you what happens with an identity. There is one of each on the test tomorrow, okay? And they're just mixed in. But the hint is there's only one of each. So if you start writing like no solution for like 6 problems in a row, there's not that many on the test that are no solution. There's only one no solution and one identity. Everything else is going to be a normal equation, just like the ones you've been doing all week. All right, so let's try this one. Actually, did I skip? I skipped 3. All right, we'll still do that other one, but we'll do, that's example 4. Let's do example 3 first. All right, so example 3. It says 2a minus 5a plus 4 equals 4 minus 3a. Now, if I didn't tell you that this was special, you'd just start solving it like you normally would. Start with your simplify. Anything that I can do under my simplify step? Shannon?
You can combine 2a and minus 5a.
Yep, I can combine 2a and minus 5a. And what do you get when you combine 2a and minus 5a?
Negative 3a.
Yep, negative 3a. And bring down everything else. Now, at this point, does anybody notice anything about this equation? It's already starting to happen that we should recognize something weird is going to happen. If you don't recognize it, you will definitely in the next step. Liam? All right, so we have a positive 4 and a positive 4, one on the left, one on the right, a negative 3a and a negative 3a, one on the left, one on the right. So basically we have the same thing on the left and the right. But let's say you didn't recognize that. You know, you're just taking the test, you don't notice it. Your next step would be, let's do our adding and subtracting. Okay? Let's put all the letters on one side. Or you can put all the numbers on one side. It doesn't really matter. This time, let's put all the letters on one side. And so Josh, do you want to put all the letters on the right? Or do you want to put all the letters on the left? On which side? On the right. So can you tell me, how would you move this to the other side? Good. You would add 3a. And Ashley, where else would you add it? Yep, right on the other side. Now here's where I want you to watch what happens. Okay, at this point, we need to see what's going to happen. Nini, what's negative 3a plus 3a? 0. That's gone. So what do I have on this side, on the left now? Just a plus 4. Okay, and on the right side, look what I have again. Negative 3a plus 3a. Emily, we just did that. What is negative 3a plus 3a?
0.
0. That's also gone. So what's on the right-hand side now? Just a 4. What happened here that's never happened before? Look at this last thing I wrote. What's not here that we usually still have at this point? Yep, Emily?
We usually still have a variable.
Right, we usually still have a letter. All the letters are gone. Okay? That's a hint that tells you, okay, something different is happening. I don't have any letters left. I just have 4 equals 4. So when you look at 4 equals 4, is that a true fact or is that false? Is 4 equal to 4? Yeah, that's true. Okay, so what that means, the solution here is all numbers. You can pick any number you want, and it's always true. Okay, so the answer here is all real numbers. Okay, so this is true. True is not the answer. True means this is the answer. Okay, so if you get a fact that's true, the answer is all real numbers. Which means you could pick absolutely anything you want and it will always work in the original equation. You'll always get the same thing on the left and the right. In fact, I don't care how hard you try, you will never find a number that doesn't work. Fractions, decimals, positives, negatives, you never will. It's impossible. Right, so any question on that special case? All the letters disappeared. We've got a statement that was true. Your answer is all real numbers. Question on example 3. Okay, so how many did I say there would be of that type on the test? Yeah,
One.
just one. There's going to be one problem that comes out all real numbers. All right, and let's try this one. It says 5 plus 2x plus x equals 5x minus 2x plus 5. Okay, I see something I'm going to have to do here, but this time it's on both sides. Does anybody see what I have to do on both sides right away? Yeah, Bay?
Combine like terms.
Yeah, I've got some like terms. Can you tell me what my like terms are on, let's start with the left.
Okay, 2x.
Positive or negative?
Negative, it's gonna be, you're gonna have, actually, yeah, positive.
That's a positive 2x
And then plus x.
and a positive x. Okay, can somebody else tell me my like terms on the other side? Yeah, Ashley? 5x, negative 2x. Let's combine everything I just circled first. Okay, the 5 wasn't circled, so we're not going to do anything with the 5. Sai, how about 2x plus x? Well, remember, what number is in front of x here that's invisible? So you have 2x plus 1x. 3, 3x, okay. So we have 3x. And now on the other side, I've got 5x minus 2x. Yeah, right?
3x.
That's 3x. And I still have a plus 5. Okay, what I'm going to do, because if I don't do anything to change this problem, it's going to come out exactly like the other one did. So instead of a plus 5, just make a small change. Make it a plus 8. Okay? So that doesn't change anything we've done so far. The only thing it changes is I'm going to put a plus 8. Okay? Because I want something different to happen this time. Okay, any question on the like terms that we just combined? All right. Now let's get all the letters on the same side. So Shannon, do you want to put all the x's on the right, or do you want to put them on the left?
Put them on the left.
Okay, so she's going to take this and move it over here. Can somebody else tell me how she would move 3x to the left side? Yeah, Liam?
Subtract from both sides.
Subtract from both sides. And Liam, what's 3x take away 3x? And the same thing happens on the other side. Right? 3x minus 3x is gone. So, Vanessa, what do I have left here? I like the equals 8, but there's still something else on the left side.
Oh, the 5.
The 5. 5 is the same as 8. Is that true? No. This is false. That's not the answer.
No answer.
This means no solution. Good. This is the kind of problem that, unfortunately, no matter how hard you try, no matter what number you ever think of, you will never find a number that works in this equation. No fraction, no positives, no negatives, no decimals. Okay? So when all your letters cancel out, one of two things happens. If they cancel out and you get a number equals the same number, that's true. The answer is all real numbers. If all your letters cancel out and you get a number equal to a different number, it doesn't mean you did anything wrong. It just means that there is no solution. So any question on that type, example 4? And how many of example 4s did I say would be on the test? Just one. Okay, and I'll even give you another hint. Everything on the test is in the order we did it. So these two are probably towards the end of the test. Okay, question on example 3 or 4? All right, last problem. I didn't know you had a pizza shop. All right, so it says size pizza shop they got two different pizzas. You charge $10 for a cheese pizza, and if you buy a cheese pizza, you pay $1.50 for each topping. Okay, but if you go down the street to Bay's Pizza, okay, Bay makes pizza too, right? You make pizza there? Yeah, he makes pizza. So Bay's Pizza charges a little bit more, a little more pricey, right? $12.50 for a cheese pizza, but they don't charge as much per topping. They only charge $1 per topping. So I want to write an equation that tells me basically when would I pay the same for a pizza from each place. All right? I want to know how many toppings would I have to get to pay the same amount for a pizza at Bay's and the same amount for a pizza at Size. All right, so we've got two different pizza places. Let's start with Size. So we've got Size Pizza. Okay, I want to write an equation that tells me the cost of a pizza at Size. Now, when you buy a pizza at Size, there's a price you pay one time, and then there's a price you pay over and over again, depending on something. Can anybody tell me which of these two do you only pay once? Josh? Yeah, you only pay the $10 one time. Okay? No matter how many toppings you get on the pizza, you only pay $10 one time. So what fee do we pay over and over? Brett? The topping fee, okay? We pay $1.50. It's expensive for toppings. Should lower the price of that. Okay, so we pay $1.50 for each topping. So anybody know how I'm going to write that? You pay $1.50 per topping. So it's going to have $1.50 in it, but we also need a variable, depending on how many toppings we get. Yeah?
So $1.50.
Yeah, sure. I think T is good because that represents toppings. So if you didn't get any toppings, you'd plug 0 in for T, and all you'd pay is $10. If you get one topping, you do $1.50 times 1, that's the topping, plus $10. If you got 4 toppings, you got to do $1.50 times 4, pay $1.50 each topping, and then add $10 for the pizza. Okay, so that's the cost at size. We'll come back to that in a second. Okay, now let's find the cost at Bay's House of Pizza. B-Hop, Bay's House of Pizza. Okay, when you buy a pizza at Bay's, what's the cost that you only pay one time? The $12.50. Doesn't matter if you get 10 toppings. You don't pay the $12.50 over and over. Okay, just pay it one time. How do I represent the cost for the toppings? What was off the screen? How much are the toppings at Bay's? $1? So how am I going to represent that? Because it's $1 for every topping you get. Yeah?
1.00T.
Yeah, you pay $1 times how many toppings you get. If you get 8 toppings, you pay $8 in toppings, plus $12.50 for the pizza. That's the cost at Bay's. Okay, any questions on the two costs? Now the question is, when would you pay the same at each place? Okay, so this is the cost at size, that's the cost at Bay's. If these two costs are going to come out the same, what's another word in math that means two things are the same? Has a symbol named after it. Two things are the same. Okay? You think of what symbol means the same? Say it one more time. Equal. Yeah, I want to know when this cost equals this cost. That's what it means for them to be the same. So now just write that down. I want to know when the cost at size is the same as the cost at Bay's. And that's the equation I need to solve. And once I solve it, that'll tell you how many toppings you need. How many toppings that you would need to order in order for the cost at size and Bay's to come out exactly the same. I just want to make sure my pluses don't look like T's. I try to curve my T a little bit. Okay. So, what would be my first step to solve this equation? I think if you do this one right, you can avoid all negative numbers. And we should be able to avoid negatives because it wouldn't make sense if the number of toppings came out negative. That doesn't really make sense. So, should not get a negative answer. So, anybody see what I should do first? Shannon?
Move the $1T to the left.
Okay, she's going to move that $1 T to the left. And Dominic, can you tell me, how do I move that $1 T to the left?
I solve it a different way.
You're not sure how to think about what's the operation in front of that $1 T? Addition. How do you do the opposite of that? Subtraction. So let's subtract $1 T from each side. All right, when I do that, how about Hannah, what happens to the 10? Yeah, we're not going to do anything with the 10 yet. That's going to be the next step. How about $1.50 T? Take away $1. What's left? Yeah, 50, 0.50. Right, $1.50, take away $1, leaves you with 50. And Bay, how about on the right-hand side? What's left there?
The 12.50.
Good, just the $12.50. Okay, I think I have 2 steps left, and then I am done. Anybody think they could tell me my second to last step? Yeah, Vanessa? Yeah. We decided to put letters on the left, so that means things without letters are going to the right. And how did you say to do it? Good. You're going to subtract 10. Subtract 10. 10 take away 10, that's gone. Not doing anything with the 0.50t. That's just going to stay right where it is. Just bring it down. But how about, can we do that without a calculator? What's 1250 take away 10? Kyle? 250. And now I'm finally at the last step. Okay. Last step, get that 0.50 on the other side. How about, Brett, are we going to add or subtract to do that? Yeah, we're going to divide. What do you divide by? 0.5. 0.50, same thing. 0.50. And I get the number of toppings equals, I need 250 divided by 0.5. So I could use my calculator, or if we know it. Yeah, it does. It comes out to 5 toppings. So if you get a pizza from Bay's and you get 5 toppings, or you get a pizza from Size and you get 5 toppings, the cost would come out the same. Now, let's say you were going to get a ton of toppings. You get like 30 toppings on the pizza. Who would it be better to get the pizza from if you're going to buy that many toppings? Well, one of them is going to start being a lot more expensive now. Okay, one of the places was cheaper at first, but if you buy a lot of toppings, who's it going to be cheaper to get the pizza from, Brett? Right, because Bay, even though he charges a little bit more money for the pizza, if you're going to buy 30 toppings, he's only $1 extra per topping, versus Cy is $1.50. So if you get 30 toppings, it's going to cost you a lot more money at Size. If you're only going to get 5 toppings, doesn't matter who you buy it from. If you're going to get less than 5 toppings, I would go with Cy. Because even though she's more money per topping, her pizza is cheaper at first. So if you're not going to get that many toppings, she's cheaper. All right. Any questions on that? Okay, so tomorrow you're going to have one just like that on the test. You're going to have to set up 2 things and set them equal. All right, so couple reminders. I think I already told you. Okay, first test is tomorrow. Okay, Mr. Ray and I made you guys a reference sheet. These problems are very similar to what's on the test. Okay, you can use this reference sheet on the test. So when you're taking your test, you can have this next to you. Okay, if you go on the Google Classroom, there are, how many problems did I say? 10. 10 questions. There are 10 spots to write your answers on this review sheet. If you write them down and you get them right, I will give you, if I pick 3 problems, you'll get 6 extra points on the test. Okay, but the thing is, you don't know which one of the 10 I'm going to pick, so you'd have to do them all. Okay, and you don't have to memorize your answers you get on the Google Classroom. You can write them right here. You do not have to show any work on the Google Classroom. Show your work on the reference sheet problems, but not on the Google Classroom ones. Okay, and if you bring in the tissues, we also said we'd give you some points for that too. Okay, any questions on that? Okay, I will also be after school today for extra help if you did need to come see me today.